So in order to get rid of a perfect cube in the denominator, I have to multiply by a perfect cube. And what I do to the bottom, I have to do to the top. Now, because it's a perfect cube I'm looking for, I need 3 of them. And that means I need to multiply by the cube root of 11 twice. So if I simplify, this is going to be 11. And in the numerator, I've got the cube root of 11 times 11, which is the cube root of 121 over 11. For the second question, I'm going to split this fraction because I'm only needing to rationalize the denominator into 2 individual radicals. And this is 54 is a fairly large number, so I'm going to actually simplify that into 27 times 2. The reason I'm doing that is because 27 is a perfect cube. You can pull it out of the radical and it becomes the cube root of 27 is 3, which means that my fraction now looks like this. And so I have to rationalize the denominator, which means get rid of the radicals. So the only one I have to get rid of is the cube root of 2. So I'm going to multiply by the cube root of 2 times the cube root of 2. That will get rid of the radical, but what I do to the bottom part of a fraction, I have to do to the top. And so all of this, the 3 is still in the denominator, but the cube root of 2, 3 times the cube root of 2 times the cube root of 2 is just 2. And in the numerator, I have the cube root of 7 times 2 times 2, which is the cube root of 28 over 6. And finally, in the last question, I'm going to multiply by the cube root of 3x squared over the cube root of 3x squared 2 times, again because I need 3 of them to be able to get rid of the radical in the denominator. So this radical down here is now gone because it's a perfect cube. It's just 3x squared. And in the numerator, I have 3 as the coefficient, and the cube root multiplying these two together, I have 9x to the 4th. So there's a bit of simplification left to do because x to the 4th is really x cubed times x to the 1. So there's a perfect cube hidden in there, plus the 3 cancels with the 3. So if I rewrite 9 times x cubed times x to the 1 over x squared, this perfect cube here can be pulled out of the radical and it becomes an x. And it's the cube root of x over x, 9 is still there, x squared. This cancels with one of those, and I end up with the cube root of 9x all over x. No radical in the denominator. It's all gone.